Hola, ¿qué tal? Muy buenas tardes a todos otra vez. Es un gusto para mí presentarles un podcast más de neurociencia para vivir mejor. Y hoy la verdad me complace muchísimo presentar a una gran amiga, la doctora Nafissa Ismail, quien es profesora de tiempo completo de la Universidad de Ottawa, de la Escuela de Psicología, adscrita a la Facultad de Ciencias Sociales. Nafi, welcome to this podcast. Thank you very much for accepting the invitation.
Oh, thank you so much for inviting me to join. It's truly an honor to be here.
Thank you. Hoy con Nafi vamos a hablar un tema que los invito muchísimo a que lo escuchen. Es un tema apasionante. Para que se den una idea, va a ser una charla que tiene que ser en inglés porque la doctora es de Canadá, pero va a hablar de un tema fantástico que vincula a la alimentación, los trastornos psiquiátricos, la biota intestinal, la pubertad y las hormonas. Y en un mundo en el que acabamos de pasar por una pandemia, con tantas personas adultas y jóvenes pasando por inflamaciones y respuestas inmunes exageradas por la enfermedad, con todos nosotros conociendo adolescentes que pasan por estos cambios hormonales y que les hacen tomar algunas conductas muy características, pues la pregunta que Nafi nos va a tratar de contestar es: ¿qué tiene que ver el paso de la pubertad como un periodo de transición en la organización del cerebro y en la susceptibilidad a algunas enfermedades psiquiátricas? Well, Nafi, your research is really interesting. I'm really amazed of how many papers you publish very often, and I try to follow them all. Thank you for the...
You publish a lot too, you know. Yeah, you're really successful as a researcher, and it's truly an honor to be present on your show here and to be able to converse with you on my research.
Well, we are part of the FAUS lab, right?
Absolutely.
So just let me remember, Nafi, when I met you was probably more than 20 years ago. I remember I met you in the whole building in downtown Montreal. You were doing some research in the 11th floor. I don't know if you remember. You were doing the thesis, and then we chat a bit, and then you eventually became part of the FAUS lab, and you pretty much became the most successful student in the FAUS lab. I can be a witness of that. You're an amazing scientist that is collecting what you planted many years ago.
Oh, well, thank you. It's a big honor. I don't know about the most successful, but truly I'm very grateful for the opportunity that Jim Fauci's lab offered, that all of you colleagues also provided in terms of support, guidance, mentorship. At the time when I joined the FAUS lab, there was a lot of questions in my mind, uncertainties. I would say that the FAUS lab gave me that space that I needed to grow and develop as a researcher and learn. And without that support, that encouragement that all of you provided, I don't think I would have been able to be a professor, a researcher, or the mentor that I am today to my students.
Yeah, the way I see it is like the FAUS lab was the fertile land. And students are fertile seeds that grow if they make a good match, you know?
Oh, absolutely. And I think it's really important in the mentorship that we receive as trainees, and thankfully, Professor Jim Faust had that ability to provide the appropriate mentorship to each student and adapted his mentorship style to each student. And I think that it's so critical because that's what helps students grow. You know, some need more structure, but some need more space. And being able to provide that is not easy as a supervisor. But he did it and provided it to us, and that really helped us develop and become who we are today, thankfully.
Yeah, some years ago, my wife had the opportunity to go to your lab and learn some techniques that we later brought to Jalapa, to this lab, and we started using something that you're gonna tell us a bit later. LPS, this lipopolysaccharide that is used to mimic some immune responses in order to study many mechanisms in the brain and behavior. But we are very thankful with you because of that opportunity that you gave to her and to me to be also a visitor in your lab. Fantastic activities, by the way.
I am the one who's really grateful to have had the opportunity to work with you both. You know, truly, it was a wonderful time.
Well, Nafi, thank you. Now, let me give a bit panorama of what you're going to talk us about. You started as a bachelor in science. You started studying feeding behavior. Then you moved to sexual behavior. Then in your postdoctoral fellowship, you did a bit of puberty and immune responses between sexes. And then you, during your, now in Ottawa, you started to explore how these different topics interact along with the intestinal microbiota, having as the main topic the gut-brain axis that functions as a connection between the microbiota that is in the intestine, the substances that it produces, and how it can affect not only behavioral responses in pubertal individuals that are in a sensitive period of development, but also long-term effects in psychological, with psychological consequences that might be even have a long-term effect in mental health. So can you, first to start with all this conversation, can you please just tell us the difference between puberty and adolescence, the way as you see it?
Oh, I love this question because often these two terms are used interchangeably, but they don't represent the same period, which I think is really important to emphasize. So puberty is part of adolescence, but it marks just the early phase of adolescence. So puberty starts when our hypothalamic pituitary gonadal axis, so the axis that connects our brain to our pituitary gland to our gonads, becomes active. With that, our ovaries and testicles are going to start producing hormones. And that is going to drive a variety of changes in our system, including reproduction, maturation of our reproductive system. And puberty ends once our reproductive system is now mature. But as we know, a lot of physiological, behavioral changes continue to occur throughout adolescence. So puberty is a much shorter period than adolescence, and it is right at the very beginning of adolescence. So they both start at the same time, but puberty ends as soon as reproductive maturity has been reached. Adolescence will continue until we reach adulthood. And I'm particularly interested in this pubertal period because it has been shown to be particularly sensitive to exposure to stress. And stress will interfere with the hormones that are then organizing our brain, that are maturing our behavior, our physiology, in a sense, preparing us for adulthood.
Right. So, can we say that adolescence represents more the social maturity of the individual rather than the reproductive maturity?
Yes. So I think adolescence is yes, it's much more. It's that emotional development, cognitive development continues during that time. Social development, as you mentioned it, also continues during that time. But reproductive maturity is reached already and does not continue to develop then into adolescence. Of course, patterns and other preferences within reproduction are going to continue and develop, but the reproductive system in its sense is fully developed and matured at the end of puberty. Now, so what this means, what this would mean is that for girls, they would now be menstruating and cycling, and that would mark the end of puberty. So the moment menstruation begins, puberty has ended, but adolescence will continue. With boys, we are going to see sperm production occur. So the moment sperm production has started, puberty ends, but adolescence continues.
So it's nice the way to see that adolescence is a period of transition between being an infant and becoming an adult. And that's the things that we should understand, that when we are dealing with an adolescent, we are dealing with someone with a brain that is in process of development. It's not fully developed. It's no longer a child, but it's no longer an adult. And this is what brings many risky behaviors, many behaviors that look normal to many adults and look like difficult to deal with. But I remember some of your publications that you show that even the stress responses are different in pubertal individuals as compared to adults. Can you remind us a bit of how different are those responses?
Absolutely. And before I begin, I just want to, if you allow me, make a distinction between good stress and bad stress, because often we tend to just see stress as being something negative for our body, for our development, for our physical, mental health. But the reality is that stress is not always bad, So I want to make that distinction because in a sense, we need stress. We need stress to be able to progress. We need stress to be able to develop ourselves, to better ourselves and our performance. Stress is what allows us to concentrate and focus on tasks that are critical at a given time point. And so stress is good. Stress like deadlines, exams, projects we need to submit. So these kind of stressors that have a deadline, that we know are going to end at a certain time, those are very good, actually. They really help us grow, develop, and mature. The stress that is bad is the chronic stress. So it's the stress that persists over time that we have no control over and that doesn't have a deadline. And we're not able to do anything to put an end to it. That kind of stressor is not only going to activate our stress response, but it will also activate our immune response. And that's where it becomes negative, So when we have just regular stressors, those just activate our stress response and our body is conceived to take those stressors. So our body will mount a stress response and then bring everything back to homeostasis once the stressor is gone. But when we get that simultaneous activation of the stress and the immune response, we see that causes inflammation in the body that can then lead to illnesses within the body, but also leads to neuroinflammation. So inflammation within the brain, and that then also leads to illnesses within the brain. So that kind of stress is bad, and that kind of stress is the type of stress we would want to avoid.
Right. But I remember the response itself, when we measure stress as corticosterone in blood, I remember seeing some graphs of your publication where pubertal individuals have higher peaks and longer curves of stress as compared to adults. Is that correct?
Yeah, so in terms of stress, what we see is that the females will mount a stronger stress response compared to males, and it will last longer too. But when we compare pubertal and adults, what we see is that actually the adults are the ones that when stressed, with a stressor that will activate both their stress and immune response, they will mount a stronger stress response with more corticosterone, more cytokines, so more inflammation within their body, and also more activated microglial cells, which are the innate immune cells that reside within our brain and that are then going to cause the neuroinflammation that we see in the brain. So the adults will respond to the stressor much stronger than will the pubertal animals. And that really surprised us when we first saw those findings a few years ago, because really we expected the opposite. But when we thought about it further, we realized that it's because in the pubertal individual, just like in pubertal animals, the stress system and the immune system are still developing and maturing. And so when we are faced with a stressor, those systems don't know how to deal with them. And because they don't react to them, they don't bring things back to homeostasis, which is really important. You want to bring your body back to homeostasis and recover from this stressor. The adults do that. They will mount a strong stress and immune response and bring everything back to homeostasis, and we don't see enduring consequences on brain functioning or behavior. But in the pubertal animals, we do, probably because the system doesn't come back to homeostasis quickly enough.
And probably also because the brain itself is more plastic at that moment, and any insult can just get out of control that plasticity, right?
Absolutely, absolutely. So during puberty, we see that the brain is being reorganized and remodeled, preparing for adulthood. But when stress is on board, there is interference happening there and impact on this normal reorganizing and remodeling, because this remodeling is happening thanks to our gonads that are producing the estradiol, the testosterone, the progesterone that we need. And these endogenous hormones within our body are going to work at the level of the brain and organize things. But when stress is present, those hormones are inhibited. And so now they are not available to organize the brain. And that is also why we are seeing these enduring consequences.
So to this point, we understand that pubertals respond differently, more disorganizedly, if we want to say that, than adults. But also between males and females, that during puberty are differences in the expression of how they respond to stress. And I remember reading your very recent paper in which you explain that estradiol actually enhances the stress responses, whereas testosterone kind of reduces the stress response. That might explain a bit how males are a bit more protected in that sense as compared to females. Can you explain us a bit more about those hormone differences in females and male response to stress?
Yes, absolutely. So what we do see, as you said so well, females tend to mount a stronger stress response, and it's because of the estradiol that they have in greater concentration compared to the males that makes them more reactive to stress. But the reaction to stress is not necessarily negative, so as long as it's there for a short period of time. So if the females are then able to recover quickly from the stressor, then everything is fine. We also see that there are benefits to having more estradiol when it comes to an immune challenge and activation of our immune system. Females will mount a stronger immune response, again, because of having more estradiol compared to males, and that will help them fight the infection, whether it be a bacterial infection or viral infection, more effectively than males will be able to fight it off. So there are benefits to having more estradiol, but it does then lead to sex differences in terms of our vulnerability to diseases, where we'll see that females are more vulnerable to certain physical and mental illnesses than are males. And males are more vulnerable to other physical and mental illnesses than are females. And we're just now starting to realize that there is this vulnerability, this sex difference in vulnerability to illnesses, and just now getting interested in understanding the mechanisms behind those sex differences.
Right. I remember reading that males might have more corticosterone receptors, which might blunt the immune response, increasing the negative feedback to decrease the levels of corticosterone, and eventually having a bad immune response because of that. I don't know if that bad immune responses are associated with what we see in many diseases out there, And probably the most recent one is COVID. If you remember, many males were more affected by the disease than females. Do you think it has something to do these mechanisms with the response?
Oh, absolutely, absolutely. We did see it at the early stages of COVID infection when the pandemic had just begun, that males mounted more stronger responses and had more stronger symptoms following a COVID infection. And they were also more likely to die from the COVID infection than were females. And it's because of that, because their immune system tends to get suppressed by increased concentration of testosterone. So it takes longer for the immune system of a male to detect the infection, and it allows enough time for the infection to start spreading, before the immune system detects it and starts to eliminate it. Whereas in the females, with the increased estradiol concentration, we detect those viruses and bacteria much faster. And so they have less time to spread before our immune system already starts attacking the pathogen, So this is why we were seeing those differences. And we see it with the flu as well. So just with influenza, we've been seeing that as well, that males are going to have stronger symptoms when they get infected with influenza compared to females, and they will also take much longer to recover from the infection. And we were able to replicate that in the lab with our mouse model.
Yeah, there is a joke here in Mexico that this guy comes to his wife and says, I think I understand the pain that you went through during parturition now that I have a flu, It's a bit unfair, but that's a joke.
That's too funny.
Yeah. So Nafi, males and females have different hormonal milieu, right? My question is, how do you explain these different hormones in the behaviors that male and females express? For instance, high risk behavior or decision making. And I'm going to stretch this question to the next level. How these hormones affect the microbiota in the intestine? Because from that, I'm going to start asking you the role of the microbiota in mental health.
Okay, yeah, thank you for this great question. I'll be happy to talk about that. So during puberty, our hormones are going to organize the brain and lead to maturation of the behavior. But when there has been stress, for example, that was present during puberty, and I'm referring to now chronic stress, so not just an activation of the stress system, but also an activation of the immune system over a long period of time, and there is neuroinflammation as well within the brain, now we'll have a pubertal brain that didn't get organized properly. And so that misorganization is going to then lead to behavioral alterations. And sometimes those behavioral alterations are manifested in the form of increased depression-like behavior, increased anxiety, also increased vulnerability to neurodegeneration later on in life. So it's really important to understand that exposure to certain stressors during puberty can really change the course of our life and increase our vulnerability to diseases for our entire lifespan. And so we're not always aware of it. Some of the stressors we can control, but some of the stressors we can't control. One stressor that I just want to quickly mention to you that females are the ones that are most affected by is oral contraception. So oral contraception acts in the body in a way that is very similar that chronic stress will, where it will also inhibit the production of the natural hormones that are needed to organize the brain. The idea is not at all to say oral contraceptives are bad, don't take them, or oral contraceptives are good, take them. That is a very personal decision, you know, and it's up to each woman, each girl to be able to take that informed decision. But it's that information that is missing to our girls and our women. And it's to understand, you know, that these decisions that we are going to take during puberty, whether it be with regards to oral contraception, whether it be with regards to drugs, etc., we are going to impact the development of our brain forever, you know. And so this is why it's important to be mindful of all that when we are making those decisions. And we've been working on trying to understand what are those mechanisms that link this exposure to stress during puberty to mental illness and neurodegeneration later on. And as you said it, the gut microbiome seems to be the mediating factor in all that.
Right. Yeah, you touch a very interesting point. Like, we have to teach the young generations, not by prohibiting them to do something, but by helping them to decide with good information. That's the only way they can decide whether or not they do something or not take something, you know?
Absolutely, absolutely.
But now, how these hormones, testosterone or estradiol, as you mentioned, might have an effect on the type of bacteria that we have in the intestine. That's the first point. How they might increase immune responses or affect the viability of these bacteria and fungi that might increase or decrease the good ones and increase the bad ones, and produce alterations in the colonies that we have out there. So this is the first question.
Yeah, and I love this question. So we don't realize this, but there is a whole host of bacteria in our gut that are living in symbiosis with us. These are bacteria that we acquired at the time of birth, that we developed through breastfeeding, through early feeding, etc., and that continue to be affected by what we eat on a daily basis. And these bacteria, they control our overall health, they control our brain and the functioning of our brain, and also then impact our behavior, you know. And we don't realize, but we truly are what we eat, you know. So so normally our gut is in symbiosis, meaning that we have an equilibrium within the bacteria in our gut. And it's very important for good health, for good physical, for good mental health, to maintain that equilibrium within the gut. But what we have realized now is when we are exposed to stress, those the bacteria with our gut get disturbed. And that disturbance then will cause a disequilibrium, where we call that in research gut dysbiosis. So that disequilibrium will make it that the bacteria that are inflammatory, that will cause inflammation in our body, will increase in concentration. And the anti-inflammatory bacteria, so those that would typically reduce the inflammation, are now going to decrease. The good news is that disequilibrium is not long-lasting. From what we see in our laboratory, that disequilibrium lasts maximum 1 week. And after that, the gut has the ability to reestablish itself. The scary part is that even a 1 week of disequilibrium within the gut is sufficient to impact brain functioning forever during puberty. And this is why it's I would say a topic of worry, because it means that even short-term perturbation can really have an impact on the pubertal brain.
You mean an enduring effect on mental health?
Oh, yes. So an enduring impact on brain functioning. We'll see alterations in cognitive functioning.
How this dysbiosis can have long-term effects in mental health of people, even 1 week.
Yeah. Yes. So what we'll see is that we'll see alterations in cognitive functioning with that with that short-term perturbation of the gut microbiota, and that will impact how we function, how we think, how we interpret things, how we behave in certain situations. And then that can then increase the likelihood of mental illnesses like depression, anxiety. It can also have an impact on post-traumatic stress disorder as well. And we also see increased vulnerability to Alzheimer's disease and also Parkinson's disease.
Nafi, I'm going to ask you something that is popping up right now as a question. Do you think this dysbiosis during puberty can also affect the sexual brain or the development of the sexual brain with all this, meaning by sexual brain, sexual orientation, gender identity, patterns of sexual behavior, patterns of arousability, desire, and even probably direct individuals towards paraphilias?
Oh, that's an excellent question. That's an excellent question. What we do see is that gut dysbiosis can impact impulsivity in individuals. And much of what you mentioned just now does relate to some form of impulsivity or erratic behavior or behavior that we didn't put much thought into it, you know. And so we do see that absolutely with gut dysbiosis. And so with the perturbation of the gut during puberty, it can have enduring effects on that. Of course, if this perturbation happens in adulthood, well, it will impact us and our behavior for a little while, maybe a week or so, but after that we recover and we are fine. It's
Right.
really in that critical window of puberty that we need to be more mindful of those perturbations. And what our research shows is that if you colonize the gut with good bacteria, like probiotics, even just a 2-week course of probiotics in our mice was sufficient to provide a long-term protection for stress-induced mental illnesses. The idea is not to say start taking probiotics, everybody, but it's just to be mindful of what we eat, because some of the food that we eat is going to promote more inflammation in our gut. Other foods that we are going to eat is going to promote anti-inflammation within the gut. So the idea is to really try to minimize that inflammation to allow the good bacteria in our gut to be able to do the work that they need to do. And so just being mindful of having a good diet will be also quite beneficial.
What I'd like you to explain to the audience is, because sometimes they think of the bacteria in the intestine and they don't see how this intestine content might affect what is going on in the brain. So what is the connection between the bacteria and the brain? Because there are two different parts of the body, right?
Oh, yes, absolutely. Absolutely. And, you know, we've been studying for many decades the brain as though it's an isolated organ, forgetting that it lives in a whole body where there are many other organs that are also present. And it hasn't been that long that we realized that there is this bi-directional communication between the gut and the brain through an axis that we call the gut-brain axis. And there is a nerve in our body that is called the vagus nerve. It's quite a major nerve. It's through there that the communication occurs between the gut and the brain. So the bacteria in the gut can impact the way that the brain will function. But in reverse, the brain can also have an impact on the type of bacteria that we will have. For example, if you take an individual that is suffering from depression and look at that individual's gut and compare that to someone who's not suffering from depression, you get very different gut profiles, And we can take then microbiota from an individual that is suffering from depression and put it into a mouse that is not displaying any symptoms of depression. And now that mouse will start developing symptoms of depression, Wow. So that really shows this bi-directional communication between our brain and our gut and the bacteria within our gut.
That's fantastic. So what about serotonin and tryptophan, these substances that actually are part of the mental health by increasing good effects and helping depressive people getting out of depression? Most of the medicines that are out there are actually meant to act on those substances, increasing dopamine availability, sometimes via tryptophan availability. So the question is, does these bacteria produce these substances in the gut and they go somehow to reach the brain areas where they are needed?
Very good question. So yes, the bacteria in the gut do produce serotonin. It's not clear though yet whether that serotonin in itself is able to cross the blood-brain barrier and reach the brain, or whether the bacteria that are serotonin producing in the gut have also the ability to promote serotonin production within the brain. We think that it's more that, and that the serotonin from the gut is not really crossing the blood-brain barrier and getting to the brain, and that it's really the serotonin that is produced within the brain that is critical in maintaining good mood and alleviating symptoms of depression. But because we know that the current pharmacological treatments that we have that target the serotonergic systems are not effective in all cases, we do think that targeting serotonin alone is not the right way to go, and that perhaps working at the level of neuroinflammation within the brain is also quite critical, because individuals who suffer from depression also have a lot of neuroinflammation compared to non-depressed individuals.
This takes us to the idea that in order to help depressive people to get out of depression, they need to act on different systems at the same time. I mean, they have to take their medications prescribed by their doctors, but they also have to start taking care of what they eat, how they are dealing with stress, with their beliefs, that sometimes is the cause of anxiety, of something that doesn't exist. And probably sleeping well, that is also a very common cause of dysregulations, stress responses, and dysbiosis, right?
Absolutely, absolutely. We do see that when we are able to regulate the sleep pattern and sleep habits in individuals that are experiencing depression, we do see a big improvement in their symptoms of depression. Similarly, when we change their diet and make it less inflammatory, again, we are able to improve symptoms of depression. But that we've also shown it for other illnesses as well. So for anxiety as well, if we are able to have a less inflammatory diet, we will improve symptoms of anxiety. Same with autism as well. And so it's important to always keep in mind that all that is interconnected, and that sleep, as you said, is so critical, where sleep is where we tend to cut, and we do it as adults, we do it as teenagers for various reasons. We've been doing it even more now since the pandemic, and that chronic lack of sleep eventually will get to us, and we need to be mindful of that.
Right. Now I would like to ask you, Nafi, in a world like our Occidental world where many junk food is out there just waiting for us to go to the corner store and get a soda and chips and etc. etc. And young people is probably the ones that are more attracted to eat that in regular basis, probably as for breakfast, lunch, and dinner, with a big giant soda. What is your perspective on trying to help adolescents in order to, as a preventive approach, to help them putting together all these topics? I mean, I know you're an adolescent. I know your behavior is risky, is out of order. You're more attracted to this type of food. You're more attracted to not sleeping well. Probably you're going to stress response is going to be higher than anybody else. You have to deal with bullies at school. You have to deal with your parents. You have to deal with social relationships. How can we help adolescents if they think the way they think?
Well, I think the key is what you are doing now is spreading that important information. So spreading that knowledge and informing our teenagers and our adolescents of the impact and choices that they make right now on their life and their health later on. Because as an adolescent, we don't have that mindset of thinking long term. We're much more into living in the present. Whereas when we become adults, we forget that of living in the present and we're more into that long term thinking, And so in some ways, those ways of thinking are very normal at the different stages of development, but we need to be more mindful of that, So as teenagers, as adolescents, we need to be more aware of the choices and behaviors that we are engaging in at the moment and the impact that it will have later on in our lives, and what type of adult we would like to be. Where do we want to see ourselves? What sort of health state do we want to be in as we age, That's something that we need to keep in mind, because we tend to think of aging as something that occurs many, many years from now. But the reality is that regardless of the age we have, every second we are aging, Right. And being mindful of that how we will be, the state that we will be in once we are older, is in some ways something that we can control now, early in life, with the correct choices of food, of behavior, of how we spend our time as well, and how much we are going to sleep, how much we're going to engage in physical activity. And so I think that the key to all that is what you are doing right now, which is spreading that knowledge and informing.
Yeah, thank you. You would like to give us your final comments and practical tips to parents and adolescents that might help them put all this information together in order to live a better life?
Well, one thing that I would like to say is that mental illness is just like any other physical illness that we can experience. It's an impact to our health and it needs to be addressed. And the earlier we can address it, the better it will be for our life, quality of life later on. We do see that 50% of adult cases of mental illnesses have actually begun during puberty and adolescence. As parents, we are the ones that know our child the most and the best. And so if we notice any behavioral changes in our child, we shouldn't just naturally associate it to hormonal changes, but rather maybe pay attention, have an open conversation with our teenager, our adolescent, and try to see if maybe some help or support might be needed. To our adolescents and teenagers, I would like to urge to get informed and learn about the consequences of what you are eating now, of what you are doing now, how you are behaving now, and how that will impact you as an individual. And bringing that mindset will be extremely important for future development.
Perfect. I'd like just to add that the way to help adolescents is teaching them how to take care of their brain, take care of their beliefs, and take care of the social circle.
Absolutely, absolutely.
Nafi, thank you very much for your time.
Thank you so much for having me.
I love this conversation, and see you soon.
Thank you for having me. And hopefully we can have another conversation together.
Definitely we will, Nafi. Thank you very much.
Thank you. Buenas tardes.
Bye.
Bye.